Okay, in today's notes we're going to continue exploring parallel lines cut by a transversal. And in the last notes we introduced vertical angles, adjacent angles, linear pairs, and then the ones that had to do with parallel lines in a transversal were the corresponding angles, which kind of face the same direction, the alternate interior angles, which make the letter Z, and then the alternate exterior angles, which open out on opposite sides of the transversal. The angle that we're going to introduce today is the consecutive interior angle. And we're on the interior of our two lines that are cut by a transversal. And if the lines are parallel, then these two angles are supplementary. So if I were to put on little tick marks here that told me that this line and this line are parallel, then we can conclude that x plus y is equal to 180 degrees. So here we have two examples that show this. In the first case, these two lines are parallel, so 120 plus our unknown, 120 degrees plus our unknown is equal to 180 degrees. These two angles are supplementary. So if we subtract 120 from both sides, we find that our unknown angle is 180 minus 120, 60 degrees. So this angle right here is 60 degrees. Okay. Pushing some algebra into the problem, we've got parallel lines. We got the double tick mark arrows, so we know the lines are parallel, which means the consecutive interior angles are going to be supplementary. And you can kind of visually see that. If you were walking along this line and then you were to turn and then you were to turn around, you more or less have done a 180 degree turn. So the first angle plus the second angle is equal to 180 degrees. If we subtract the 120 to the right hand side, we have 12 plus 4x is equal to 60. Then we subtract 12 from both sides. 60 minus 12 is 48. And then we divide both sides by 4, and we arrive at the answer x is equal to 12. Okay. So consecutive interior angles add up to 180 degrees if the lines are parallel. Okay, so we have several diagrams here, and we're going to kind of pull together all of the different types of angles that we have and use the information of what type of angle they are to draw more conclusions. So when I look at this line, I've got a transversal cutting through parallel lines, but I've got two angles that are side by side along a singular line. So that is a linear pair. And because it is a linear pair, we know that the angles are supplementary. And what that means is the two angles add up to 180 degrees. So this angle plus this angle adds up to 180 degrees. So as I merged my like terms together, 24 plus 14x, 24x plus 14x is 38x. Negative 5 plus negative 5 is negative 10. If we want to keep our degrees on there. Then if I were to add 10 degrees to both sides, I would have 38x degrees is equal to 190 degrees. And then if I were to divide both sides by 38 degrees, I would find that x is equal to 190 over 38, which is 5. Okay. On to the next one. I have two angles that are opening in the same direction. They're on the same side of the transversal. One's an interior, one's an exterior. That tells me they're corresponding. corresponding angles are congruent if the two lines are parallel. And the two lines are parallel, so we can say that the two angles are congruent. So the angle 12x plus 14 is equal to 14x minus 2. Or if we ignore the degree symbol, we can just write 12x plus 14 equals 14x minus 2. Subtract 12x from both sides. 14 equals 2x minus 2. Add 2 to both sides. 16 equals 2x. And then divide both sides by 2. And we get 8 equals x. Right. And on the last diagram, I have two parallel lines cut by transversal. The angles that I'm interested in don't even rely on this lower parallel line, so we don't even need that knowledge to do the problem. What we have is two angles that are on opposite or are standing vertical to one another. So these are vertical angles. So vertical angles. This line was thrown in as a little bit of a distractor because we only need two lines to make those angles. Vertical angles are congruent, so we can say that the angle 6x plus 4 degrees is the same as the angle 7x minus 7 degrees. If we strip out the unit from the problem, we have a linear equation that we can then solve by combining like terms. Subtract 6x from both sides, and we get 4 equals x minus 7. Add 7 to both sides, and we get 11 is equal to x.